So the third mission we talked a little bit about last month. It had just barely happened, and this is the newest mission to arrive. It's called the ExoMars Trace Gas Orbiter. This is built by the European Space Agency, and it also had a landing demonstration module to test out the various technologies that they'll need on the next mission when they try to land a rover. This was called Schiaparelli. And the way this worked, about 3 days out from Mars, they dropped off the Schiaparelli capsule. The Trace Gas Orbiter fired its onboard rocket engine to slow down and be captured into Mars orbit. And that at the same time, the Schiaparelli was intended to come down under a parachute and then fire retro rockets and softly land on the surface. What happened is they lost contact with it, and a few days later, NASA's Mars Reconnaissance Orbiter flew overhead, and with its very high-resolution, high-rise camera, it saw the debris left over from this mission. This is the parachute. This is the heat shield that apparently came off properly, and then this is the landing craft itself. And the thinking is, well, I'll tell you what they think happened, but just looking at this picture, this hit at much too high a velocity, and they believe this pattern was caused by the fuel tanks exploding when it hit. These are pieces of debris from the craft itself, and this is probably some smaller debris that rolled across the surface, and it's actually small enough that we can't resolve it with the camera. So that attempt did not go so well. So here's what should have happened. They hit the atmosphere at about 21,000 kilometers per hour, the upper atmosphere. They have a heat shield that slows them down at about 1,700 kilometers an hour. They pop a parachute, they drop off the heat shield, and then at about 1.2 kilometers from the surface, they would drop the Schiaparelli capsule off, and it would ignite its engines and settle down onto the surface. So they did get a lot of telemetry back from Schiaparelli. This part all worked fine up to this point, except right when the heat shield dropped off, they had an error in the inertial measurement unit on board the spacecraft, and that's, for lack of better words, it's onboard gyroscopes that they're solid state, but they can measure the orientation and the rotation around any of the axes on the spacecraft. And it turns out they had a 1-second glitch in the inertial measurement unit where it saturated. All of the different channels measured the maximum value that they could possibly measure. And the onboard computer system interpreted that as being, I'm already on the surface. And so what it did is it cut off the parachute, it dropped the lander, the engines fired for a little less than 4 seconds, and they shut off about 4 kilometers above the surface. And then it fell the rest of the way. And it impacted at somewhere between 500 and 600 kilometers per hour, which is a lot more than the walking speed that they intended to touch down with. So so they know what caused the problem. They don't know why yet that the problem happened. What caused the IMU to give the false readings, and they're certainly looking at the computer program on board, the control system for why it would interpret the data the way that it did. So there's lots of lessons that will be learned. The successful part of this is they got a treasure trove of data back, so they will be able to figure it out. and be able to apply whatever the findings are to make sure this doesn't happen on the next mission. So meanwhile, the trace gas orbiter, they're still adjusting its orbit, but they just did a test 2 days ago with this instrument. It's called Electra. It's a radio transmitter receiver that is designed to talk to other spacecraft. And so we've had these on our American orbiting spacecraft since Mars Odyssey got to Mars in 2001, and they're used to communicate with the rovers or landers on the surface. And so it's a way to dramatically increase the amount of data you get back, that the surface spacecraft talks to the orbiter as it passes directly overhead. The orbiter records the data, and then it uses its much higher powered transmitters to get the data all back to Earth. So they've added this to the trace gas orbiter, and just 2 days ago they did a test. This is the orbit of TGO, and they overflew the Opportunity rover, and they had a very successful test of turning on Electra and handshaking back and forth, both transmitting to the rover and getting data back off the rover. So that gives us, let's see, we've got 1, 2, 3, 4, 5 spacecraft in orbit with that device on board. So that gives us lots of opportunities to hear from these landed missions, and they'll be used for future missions as well. So we've got our own communication satellite network around Mars at this point.